Now this illustration deals with location in accordance with NEC 230.70A. Notice to the left you have a service disconnect. Now that service disconnect has to be looked at and reviewed with sections of Article 230, so we list the two main sections, 230.70A and 230.79. Notice we have the meter on the outside of the building. We nipple through the wall to the panel board and the disconnect, the disconnect and main. Now notice in previous illustrations we said the main and that service disconnect would typically be regulated by 404.8A, and the main in the own position to the center of the handle would be 6 foot 7 inches. The NEC loop now for this particular part of the illustration and the drawings, we refer you to 230.42A1, which sizes those service conductors at the weatherhead routed through the service mast through the meter to the disconnecting means and the panel inside the facility. 230.90A lists the method with exceptions how the overcurrent protection device could be sized. And then 230.42A2 deals where naturally in some cases everything's 100% rated. Now let's review the illustration now to the right. Now notice the loop changes a little bit in the NEC. Why? Because we have, if you review the very bottom of the illustration, we have a combination meter with a service disconnect there. That's a main protective device also in accordance with 230.70A, 230.79, but also 408.36 because it's a feeder routed from that disconnect and overcurrent device in the combination meter. We're routed to the panel board inside, and we can just hit the lugs only. That's what we call a sub-panel. And the feeder conductors, or service entrance cable, we're hitting the main lugs of that panel board in accordance with 408.36. And notice we're connecting the neutral bar and the grounded bar. We isolate the neutral. We connect the grounded bar where we terminate the equipment grounds. All your neutrals terminate to the isolation bar in accordance with 408.40. So the NEC loop naturally is going to change here because of the combination overcurrent device and disconnect in the combination meter. Basically, there's an overcurrent device with protection and a disconnect means ahead of the meter, or I shouldn't say ahead of the meter, but ahead of the service equipment inside the building. So 215.2A1 little a now, we start off with that to size the conductors from the load side of that disconnect switch and overcurrent device to that sub-panel inside the building. And 225.8 is another section that we really need to look at. 230.42A1 has to be reviewed again because we're sizing the conductors from the weatherhead and the service drop down through the service mast to the line side of that disconnecting means an overcurrent device. And then of course 240.4 has to be applied because if the equipment is 100 amps or less, we can round the overcurrent device up. If the overcurrent device is over 800 amps, we'd have to round it down. With that, we apply 240.91, and this facility is considered an industrial supervised location as defined in 240.90 and 92 of the NEC. So kind of keep this in mind that if you have a main disconnect, either outside underneath the meter or it's a combination type meter is shown, then the conductors going inside the building, they're feeders. They're feeder conductors. And they can be routed as far as you want to run them, as long as voltage drop does not become a problem. But the illustration to the left, not so, because the first disconnecting means is located in that service equipment, and we do not have a combination meter. So with a overcurrent device and disconnecting means. So figure 6-35 is dealing with the location of the service disconnect and overcurrent protection is illustrated and shown in the NEC 230.70A.